Okay, hello, it's Miss Ruth, and I'm here to do some acid-base experiments with different household items. Here are household items, some of them that we chose, and my son Benjamin and Hank are here to help out with the testing. So first, we have made a chart. I'll show it to you, maybe. And it has all of the ingredients that we've used, plus our hypothesized whether we think it's an acid or a base. So Ben and Hank took turns on which one and alternated which they thought was an acid or a base, or they may have thought it was neutral, and if so, they called it an N. So we have drain opener, distilled water, ammonia, vinegar, well water, citric acid, baking soda, rainwater, dish detergent, bar soap, and some kombucha that we're going to test. And you can see what they thought there, whether it was an acid or a base. And the way we can determine that is by using an indicator. So our indicator that we're going to use is this. This is a wide range indicator. It's a liquid, and we're going to put 10 drops in each of our test tubes that have been labeled with each of our substances on them. And other indicators, so an indicator is something that changes color based on when it's in the presence of an acid or a base. And one of those that you have probably heard about in your book is litmus paper. So this is a neutral litmus. You can have red litmus, blue litmus, or neutral. And the neutral looks like this, and it will turn blue in the presence of a base and red in the presence of an acid. And another indicator that's a little bit more wide range is this one. And this one has lots of different colors that it can do. And with it, we can start to get numbers. And it's another little strip that you would dip into the substance. So instead of that, we're going to use, again, our drops. And this is also a wide range indicator. So it turns pink in the presence of an acid and blue in the presence of a base, but we also get all of these different colors. And these are the different, this is our chart that we're going to use to determine a number for our substances. So as we do our tests, we'll find out what our pH number is. So that's on the pH scale that goes from 1 to 14, with 1 to 7 being acidic, and 7 to 14 being basic, and 7 being neutral. And we'll also record what color we get. And then we'll be able to tell whether it really was an acid or a base. Okay, so are we ready to get started? Yes. Okay, so you record.
Okay.
And Ben, you'll be the next one. So this is our first one. So our first one is drain opener. So we're not going to talk about what's in drain opener until the end. But this is our drain opener. And we're going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 drops. We're going to give it a little shake. As you can see, it's starting to turn a crazy blue color. So that crazy purple color is probably even down below our 10.5. So it's probably more basic than that. So we're going to say it's a blue color and our pH is greater than 10.5. So blue color greater than 10.5. Okay, Benjamin, you're up next. So you are going to do number 2, which is distilled water. So our distilled water. So you should have a hypothesis on what you think is going to happen. We said we thought it was neutral. Ben's going to add 10 drops to it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to give it a little shake. Woo! So he's trying to make a mess. We'll invert it.
What's this?
And that's a beautiful color. And it is right about 7. So with this one, our pH is 7. And our color is kind of a greenish yellow. Okay. So now it's Hank's turn. And he's going to test our number 3. Testing our number 3. So number 3 is ammonia. Ammonia is another really stinky one. So he's going to do his 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoa! And this one's another one that turned a crazy color. Mr. It's going to invert. And we've got a nice purple color, kind of a blue purple. And it's going to have a number of about 10.5. So write 10.5 right there. So we'll put it back. And Benjamin's up next. And he's going to test vinegar. So vinegar's our next one, number 4. And we think it's an acid, but we'll see.
Apparently.
So we'll add our 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and we're going to invert it. And we can see its color, nice pretty pink.
Ugh.
And we're going to say it's around 3.0. 3.0 and pink. So we'll put it back. And it is now Hank's turn. Pink. Come on. So put pink. And our next one is going to be number 5. And number 5 is our well water. Our well water. And we think it's basic, but we'll see. We'll see. So if it's basic, it's going to be on the blue side. And if it's acidic, it's going to be on the pink side. 1, 2, 3, 4, 5, 6, 7, 9, 10. And we'll invert it. And oh, look at that. Wow. It's maybe around 9. So it's got a number of 9. It's got a number of 9. And it's kind of a blue-green. Blue-green. Teal. Teal's a good color. And now it's Ben's turn. And our next one is going to be number 6. Number 6 is citric acid. Bet you can't guess what that one's going to be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we're going to invert it.
Yeah, that's definitely an acid.
Definitely an acid. So that one's 3.0 and pink. 3.0 and pink. And our next one is going to be Hank's turn. And Hank's going to do this one that's starting to bubble a little bit. Ooh, that's weird. This is baking soda. And we seem to think baking soda is going to be a base. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll invert. Oh, look at that. It's not as strong as some of our other bases that we've seen. Maybe about 8.5. So a pH of 8.5 and it's green. 8.5 and it's green. So our next one is going to be Ben. And Ben's doing number 8. Ooh, we had some rain this morning. So we collected some rainwater. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we thought it was going to be acidic. Let's see, we're going to flip it over. That was our guess, but whoa, look at that.
You didn't think of
Wow. And it's basic. It's got a pH of around 9. That was kind of surprising.
Whoa.
So it's kind of a dark, kind of a blue color. Nice blue. Okay, and so now it's Hank's turn. And Hank's going to do dish detergent. So here's our dish detergent, and it's been dissolved in a little bit of distilled water. So our dish detergent, 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Ooh,
So our dish
I can already
detergent.
kind of see what it is. I think it's 5.5.
Ben's making a guess that it's 5.5, and he's pretty close.
Yes.
Somewhere between 5.5 and 6.0. Yeah. So we'll put 5.5 there, and say that it's kind of a yellow.
Are we going to test using
No, we won't test those. And this is our next one. This is number 10. So number 10 Ben's going to do, and it's bar soap. You can see the bar soap sitting there a little bit in the bottom. And it was yellow to start with. And we said the bar soap would be neutral. So now we're going to test it.
Wait, what's neutral supposed to be?
Neutral will be about 7, so it'll be kind of a greenish yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we're going to invert it. Ooh, that looks gross.
It's chunky.
A little chunky, but it's way on the basic side. Maybe about a 9.5.
Ooh.
So it's on the basic
Dark
side.
too.
Now look at this. So this is the bar soap and this is the dish detergent. So even though we use both of them as soaps, they both have very different looks to them. So that's pretty interesting. One's a little bit acidic and one's a little bit basic. All right, our last one is the kombucha. So it's
acid. It's acidic.
it tastes kind of vinegary, so we think it's
an
an acid.
It has to be an acid.
1, 2, 3, 4, 5, 6, 7, 8. Sorry, I get caught up on 7, but we were supposed to do 10, but that's okay. All right, and we were right. It's about 3.0, so it's an acid.
Wait, what's the color of it?
Pink. So it's got a pink color. So now we're going to come back and look at our chart and see what's changed and see what we can say about that. So that one is kind of a greenish blue. So we're going to say blue-green. Okay, so here's our chart. So our drain opener we said was an acid, and it had a pH of greater than 10.5. So was our hypothesis correct? No, it was a base. And if you look at the Mr. Plumber, somewhere on it, it tells you that it contains sodium hypochlorite and sodium hydroxide. And sodium hydroxide is Na, sodium, OH is the hydroxide part. And that OH tells us that we've got a base. Because remember, if you see an H at the beginning, it's an acid. And if you see OH at the end, it's a base. That's one of the ways that you can tell acids and bases apart. So our next one is distilled water. So distilled water should be neutral. It should be right at 7. And it was right at 7. So it was neutral. Okay, and ammonia is that weird base that doesn't follow that OH rule. So that's one of the ones that your book talked about is memorizing. So it's NH3. So our ammonia was 10.5, greater than 7. So that's right, Ben. It's a base. Okay, and our vinegar is its other name is acetic acid, so we expect it to be an acid. And it was. It's an acid. Our well water was at about 9, which was kind of surprising. I didn't know what it was going to look like. But well water it's groundwater that gets filtered through the earth, so there's an opportunity for it to pick up a lot of nutrients and minerals. So that has a pH of 9, so it's a base. And that's right, when we cooked cabbage, our red cabbage turned blue, didn't it? Yeah, I forgot about that. And our citric acid again, citric acid. And it has a pH of lower than 7, so it's an acid. And citric acid is the stuff that's in citrus fruits, and it's also in sodas and those things that taste real sour, that candy that you like that tastes real sour. So baking soda, now baking soda and vinegar react and make lots of bubbles and coolness. And baking soda is a mild base. So we can see it's got a pH of around 8.5, so it's a base. Our rainwater, very surprising, it was also coming off of our roof. So I don't know if the roof makes any difference with that, but I collected it from the roof. So that has a pH of 9. So that's a base. And
I guess
our
have something.
dish detergent, which we use to wash dishes and everything, had a pH of around 5.5 to 6. So it's a little bit acidic.
But it does eat away at stuff.
Maybe. It helps to clean up stuff that way. And our bar soap, which we use on our bodies to get clean, it has a pH of 9.5. And if you think about it, it feels slippery. So that slippery is another trait that bases have. So it is a base. And then our kombucha, we said that it tasted a lot like vinegar. And we were correct. It is basic. And it had a 3.0. And vinegar was up there at a 3.0 too. So that's why it tastes so much like vinegar. They're very close on the numbers.
Kombucha wasn't the base.
Kombucha was an acid. I'm sorry, an acid.
Yeah.
That's why it tasted so much like vinegar. It's because it's an acid. Ruth got confused. I know you found that hard to believe. All right. Well, this was our lab. So we've tested our hypotheses, saw what we thought and what our actual results were, and we got our numbers of pH. And if we were feeling wild and crazy, we could graph that, and we could put it into a graph from our lowest pH to our highest pH and see how each of these fit onto that chart, and that'd be pretty cool. Yeah. All right, thanks for listening. Have a good day.
Bye.
Bye.
Bye. Now can we blow it up?
Okay, we didn't do this on the last one, and we should have. Here's our rainbow of colors that we had from all of our tests. So that's pretty cool to see. All right. Thanks.
For real this time. Bye. Yeah. Seriously, bye.
Okay. If you remember, Miss Ruth was very surprised that our rainwater was as basic as we saw. And we did the test again. And this is what we found. So our pH was closer to 6.5. And we tested it with our strips and our litmus paper. Didn't really change color, and our wide range indicator stayed in the yellow range. So that told me that something was wrong. So our test tube that we used must have been contaminated. So that's why it's good to do replication, which we've talked about. And if you've got an idea in your mind and your hypothesis is proven wrong, don't always assume that it's not some sort of human error. So do your research and make sure that you know what's going on. All right. This time we're really saying goodbye.
Maybe.
Not maybe. Bye.